Hi everyone, welcome to another episode of the Hot Seat, a wireless design and development interview series where we talk about the latest wireless technologies, components, and design issues for the wireless design engineering community. Today we are speaking with Ryan Chappell, who is Global Business Development Manager, Optical Cabling at TE Connectivity. Ryan began his career in the optics industry in 1994 and has held various roles with multiple companies in research and development, engineering, marketing, and sales of optical cable, optical fiber, and other components of optical cable. Today, Ryan will be discussing the new hybrid fiber power cable system. Welcome, Ryan. What was occurring in the industry that created the need for the hybrid fiber power cable system?
So we started the project because of small cells. Small cell is basically like a mini base station. The idea is that as telephone operators mobile operators move more and more to higher and higher data rates, 4G and beyond, there's this drive that as you increase data rates, the effective area of the base station decreases, and there's a need to put these small cells. Some people say pico cells or metro cells. There's a lot of this terminology used. Anyway, you want to put these devices in places to fix the problems where you don't have proper 4G coverage, right? So you want to put them in between buildings or on lampposts or in weird locations and use that to help fix the wireless coverage problem. Well, putting them into strange locations, all of a sudden you start to find that getting power to these locations is a problem. You can run an optical cable, but to run both a power cable long distances, that's expensive. There's multiple cables. And then, you would think normally you could get local power in a lot of these places, and you can in a lot of places, like on a telephone pole or on the side of a building or something like that. But being able to tap into that power often is a negotiation with the person that owns the building or with the utility company or what have you, and that causes a lot of complexity up front. And so we started the project thinking that this coming wave of small cells, which you can see a lot of reports about on the internet, published by marketing companies, about the number of small cells that are going to be deployed in the coming years. I mean, we were looking at that a year and a half ago, and we were saying, well, we could probably do something to help speed these things up by creating a really fast to access, fast to deploy hybrid cable. That's what started the project. And then since then, we've seen that not only just the small cells are desired to be or going to be deployed in large numbers, it's also Wi-Fi hotspots and security cameras. We see maybe arguably security cameras right now is probably a bigger application than small cells. And then the Wi-Fi hot access points, same story. Basically, people want to use those to take data, to handle data offloading for the cell phone tower sites, or put in shopping centers. And anyway, the cameras, Wi-Fi hotspots, and small cells are really the three devices that we see are going to be deployed more and more and more in the next decade. And it's very difficult sometimes to get power and communications to the site. That's what started.
Can you explain the technology behind the cable system and some of the benefits it provides for your customers?
Hybrid optical cables have been around for a while, so let's state that first. I've been doing fiber optic cable for 20 years. And in the 20 years I've been doing it, I've seen that hybrid cables really haven't changed much. There's some people would say composite cables. Some of those cables, here's an example, they look like this, some of them. So there's this one that actually has two 6-gauge copper conductors. It's very complicated, these cable designs. So that's the kind of cable that's been made for 20 years. And today, if you look on what you can buy on the market, they're not much different than that. The problem is they're too big, they're too complicated, and they take way too long to access the cable, to terminate the cable so that you can get to the copper and the fiber. So what we said was that we thought we had some clever ideas for how to make a cable that would be a lot smaller, faster to deploy, and easier to access. And so that's what we did. We made a rule that we wanted a cable that we could access in about 30 seconds, whereas it takes that big complicated cable 2-3 minutes. The cable we came up with looks like this. This is a 16-gauge version. By the way, the one I just showed you is a 6-gauge copper. It's much bigger, so this is not apples and apples. I mean, this is a smaller cable, but that cable with 16-gauge conductors, I don't have a sample here with me, but would be bigger than this, but not as much of a difference. So long story short, we came up with a cable design that we can access really super fast, and we can make it in one manufacturing step, where those bigger, more complicated composite cables, they take a lot of manufacturing steps, 3-4 manufacturing steps, and that adds cost to them. So that was the first thing. Well, the cable turns out only to be a part of what we needed to do, because what we did a year ago is we took cable, we made a prototype of the one I just showed you, and we built a real working system. So it was a real tabletop model, like you were doing a high school science project almost. I had a laptop running a web server and this example of hybrid cable, and we took a regular Wi-Fi 802.11 router like you have in your home, regular Wi-Fi router, and we were showing how we could use a hybrid cable to both power and communicate, right? Well, talking to customers and showing them the cable, and the point of the demo was to show the cable, but what I started to find out, I must have talked to 20 or 30 different installers, operators. What I found out was just that cable, yeah, that's pretty interesting. Yeah, I got that it's faster to access, it's smaller, and blah, blah, blah. But most people didn't really understand how to get power onto the cable or take power off the cable on the other end. So, it wasn't enough to just come with and say, hey, here's a great hybrid cable that's cheaper than any other hybrid cable, you can access it faster. Most customers, when you say, hey, here's your cable, go deploy it, many of them will just give me a blank face. They didn't really understand what kind of electrical protection they needed, and they didn't really understand this kind of problem of how you actually engineer the system. How do you handle this fundamental problem of voltage drop over distance, where you start with a power supply that outputs, let's say, 48 volts DC, for example, and ideally you want to go maybe a kilometer that way and install a Wi-Fi hotspot, and 500 meters that way and install a security camera, and 200 meters that way and 2 kilometers back behind you. These varying distances, what happens is you have very different voltages left over at the end, potentially a really wide range of voltage, and that fundamental problem means that you almost have had to be an electrical engineer to deploy any kind of hybrid cable up until now, because you had to understand how to make all the electrical calculations for voltage drop over distance, how much current you've lost, blah, blah, blah. So what we realized was that we could bring something really valuable to that, to solve that problem and take the engineering out of it. What we realized is we could incorporate DC to DC electrical conversion in our electronics at the far end where your device is located. So what we do is, in our electronics with this DC to DC compensation, conversion, we take this really wide range of voltage and we give you back out 12 volts, or we give you back out 48 volts, whichever is needed for the device. Or we also realize that many of the devices need really an Ethernet connection. So we put a media converter in as well, so we can give you the power of Ethernet connection. Out of that, HD security cameras and Wi-Fi hotspots in particular, people are talking about making these directly optical fiber fed, but the reality is, if you look in the world today, the vast majority of these things expect an Ethernet, regular category 5 cable like you plug in to power over Ethernet with power. So I mean, those are the hallmarks of, I would say, of the technology. It's a clever cable, and then it's also electronics that provides electrical protection and this power management feature that just eliminates the engineering out of it. So we tell customers, basically, if you know how much power your device needs, we have a lookup chart, and we say, don't go beyond this maximum distance, and as long as you stay in that distance, it just works.
So then, in what other ways does the hybrid fiber power cable system set the bar for other cabling systems that are out there on the market?
Yeah, so like I said, these hybrid cables have been around for a while. It's not new to think about putting copper and fiber together in the same cable. But the difficulty, I'm going to go back to show you this one again. The difficulty here is that to access this kind of cable, you have to ring cut the jacket. You've got to take away all of these external elements. Then you can unwrap the copper around in the central element, unwrap the fiber. Then you got to do something with the central buffer tube. I mean, that really does literally take some minutes, to prep one end of a cable. And imagine now you're going to install thousands of security cameras, and you're going to pay a guy out in the field to do that. I mean, you really want it to be fast. So I can show you here the way that the cable works. We have these stress concentrators in the cable that allow you to really nicely banana peel away. I don't know if you can see that on the screen. Really nicely banana peel away the copper conductor. And so what you can do is just on the end of the cable looks like this, flat. You can just, with one set of clippers, just snip, snip, and then do that nice banana peel like I just showed you. I mean, really, that's why 30 seconds to access this cable. The other cool thing is that once you've done that, you've done what I just showed you, and you banana peel the cable, and you got your copper, and you got your fiber. With one set of wire strippers, 16 gauge or 12 gauge, because that's the two flavors of cable we offer, you can strip the copper, and then you can also access the center element. So really, if it's one tool, like a fairly cheap pair of strip wire strippers like these are like the cheapest ones I could find from a local store, and they work great, by the way. So with one tool in your hand, you can do this cable in 30 seconds and be ready to splice the fiber and terminate it, versus taking, call it 5 minutes. Even more parent companies who laugh at me when I tell them you can access these cables in only a few minutes, because they'll say it takes them a lot longer, especially if they want to open up 5 meters of cable or something like that. So, I mean, I think that is one aspect. The other aspect is that what I have seen, at least up until now, is that this problem of understanding the whole system and knowing how to take into account this idea of voltage drop over distance, like I was saying before. I mean, most people are just making a cable and they're coming to a customer saying, hey, here's a cable. But I think what we really are doing in setting the bar is we're looking at the whole system. So everything from power supply, electrical protection, the cable, the closure, which is IP67 protected, weather protected for the outdoor environment. We really are saying, here's everything you need. So as a customer, just take out all that complexity and just simply install the system that works. By the way, system, another important aspect is setting the bar. We designed the whole thing to operate where no electrician is. So we're staying inside of NEC Class 2 in the USA, or SELV electrical codes within Europe and other places of the world, so that, saving electrician, that's another way you really can save a lot of money on the upfront installation.
Well, that was my final question for you today, Ryan. Is there anything else you would like to add or comment that you think is important for our viewers to know about this hybrid cable system that you produced?
Yeah, I would say you can find the data sheets and the application note, and there's a video or two of me on there showing how flexible the cable is and some other things about that at te.com/poweredfiber.
Okay.
Yeah, so all of the information is on there, as well as a little presentation.
I want to thank you, Ryan, for joining us on today's episode and talking about the hybrid fiber power cable system. For WDD, I'm Megan Zimba, and I'll see you next time in the hot seat.